don't know where we stopped at in the review book, but I think we were on unit 2.
Yeah,
Yes. Were we on unit 2? I believe so.
yes. We were on the calculator section.
Okay.
We were
We talked.
finishing up on this one.
Okay. So yes. Oh, I was going over this. Do as much as you can in the calculator, right? If it's the calculator section, do as much as you can in the calculator. Okay. That's the goal here. So when you're looking at the options here, we had AB squared equals 59, and we had AB to the 8 equals 118. And it's asking you to find an exponential model. So I'm going to show you guys what I mean by using the calculator.
Wait,
I think we're on the calculator section, FRQ 2.
like
Mock exam, part A, FRQs. It was the one with the exponential model. It says in ecologists. It's on the horizontal paper, I think. Ecologists. Yeah. Yeah. And then, yeah. All right. So let's go to our handy dandy calculator. So remember, you'll be given the testing calculator. So this is what your calculator would look like. I'm going to add a table. And in this table, I'm going to put the given values from my problem. So in our problem, we were given that P of 2 is 59 and P of 8 is 18. So P of 2 is 59. P of 8, right, is 118. Okay, so I'm going to magnify it, and there's my graph. And I need to find an exponential. Do you see right here this little music note looking thing? If you were looking through your binder, this is something that they added to Desmos, and it's a quick way to find a regression model.
Yeah, that's in the college board version.
Uh-huh.
Yes, I know.
Yes.
I didn't remember any of the.
And so if I'm looking for an exponential, I can go over here and look what values it gives me. Okay. Are those not the values that we got? Yep.
That was really the whole reason why I didn't use the college board version.
Yeah, they added it. So you don't have to remember the codes anymore. They added the little music note thing. I don't know what else to call it, but they added, and now they have them all listed. Okay. So if you choose to use it, it is on here, and without doing, it's a calculator. Use the calculator, right? And bam, do we have the answers they asked us for? That's our A and our B. Yeah. So we have our A.
You could also use it to predict values too.
So, but it just asks you to set up. So on I, it wants you to, now you can predict your values, exactly. But you have to write it as a function to predict your values, okay? So it asks you to set up. So part I is setting it up as an equation. So setting up your two exponential equations, but part I is about solving for your A and your B. And you can use, all they're looking for is the values of A and B to get your points, okay? Hey. Yes. They have to be, well, they have to be the right equations. Desmos is giving you the answer to part 2. Part 1, you have to do on your own. It's just a setup.
But as long as we have A equals 46.1 and B equals 1, whatever.
That gives you the full points for part 2.
Right.
Yes. Does that make sense? Okay. So part A1, you have to set it up, but A2, you just have to solve, and how you solve it is up to you. Could you solve it algebraically with the use of a calculator? Yes. But why when you can just use the entire calculator, correct? Okay. Does that make sense? I know, Hudson. We know how you feel.
You have oatmeal cream pies?
They're for the teachers.
I'm a teacher.
You're not a teacher.
I teach my little sisters how to be a.
I love that for you, but you're not a teacher. All right. And average rate of change, guys, you literally will break my heart if you miss average rate of change on this test.
A-Rock.
If you miss A-Rock, you will break my heart. My achy, breaky heart. Okay. Huh? So remember, it's essentially just slope, right? Y2 minus Y1 over X2 minus X1. You have to have the 9.8 and explain what it means. Okay. When you explain what it means, that means you're describing what's in the numerator and what's in the denominator. So my numerator was describing the plants. The denominator is describing the year, which is why my reason is it is an average rate of change is 9.833 plants per year. Okay. Numerator is your beginning of your per. Denominator is the end of your per. Make sense? To get the full point, you do have to label what the average rate of change units are. You can't just put 9.833. That's only a half a point. Yeah, you have to put what the.
You actually already went over this problem.
Yes. But I'm saying for now, give yourself the one, but I'm letting you know for testing and scoring that you're only going to get half a point. Does that make sense? Okay. Because I'm glad if you can just find it. All right. Now it says the average rate of change is from P of 8 to P of 2. It doesn't let me go any further. Yeah. It says the secant line between. I got to go to the next page. That's why I can't scroll down anymore. Zip back in and hide you.
So all we have to do is have 137 and 138.
Mm-hmm. Okay, so now it's asking you for your secant line. Your secant line is just what? A linear, right? So now you're asking for the secant line between these 2 points. I'm going to go show you what that looks like. So you just got to find the value. Was it 10 or was it? Of 10 years. So it's asking you what would be the approximate value of 10. So let's go back to I couldn't remember what number we were looking for. Our value. When you want to find a value, you have to use f of x. So I'm going to write f of x equals, and I'm going to put in our equation. I'm going to I found my bucket of mice for y'all, for computer mice. So if you don't want to use it, I have the bucket of mice, and you can use an actual mouse. What? Oh, computer mice. It's in computer mice. Okay. Notice that all I did was copy and paste it into here. And now when you're looking for a value, you can just write f of 10 or f of 1, f of 10, whatever you need to type it in order to find that value. Does that make sense? Okay. But you only can do that if you take your regression model and write it in function notation. If you do not take your regression model and write it in function notation, then you're not going to be able to plug in and find values. Make sense? Are you with me? Okay. Which one are we at?
There.
Okay. Let me get back to the mouse, the window. What is my computer doing? I think that's a little dramatic. On part 3, to get your 1 point, it's asking you to explain what does the average rate of change mean in terms of this problem, okay? So when you're looking at the point, that secant line that passes through 2, comma, P of 2 and 8, P, comma, 8, because the graph is concaved up. So this is where you're describing the concavity. Does that make sense? You're describing the concavity and you're describing the secant line where the slope is positive or negative. And because of that, then is gonna ask you how would you estimate the average change is less than the value of P of T. It's just literally throw some words in there about concavity, the interval, and the secant, and you should get some kind of points out of it. But it's asking you to describe how would you approximate. So this is where us using our words, complete sentences, comes into play. And that's the last of that part. Then the next is part C. So part C, it says for which t value, t equals 6 and t equals 20, should the ecologist have more confidence in when using the model P? Give a reason for your answer in the context problem, okay? I respect that. Yeah. 1. Every question is 1. So basically what Hudson said, you know for a fact that it goes up to 6 years, right? But you do not know that it goes past that, right? Or past 8. And so using the 6 would be where your confidence lies because that is information that you can compare and contrast. You do not have to write this full on sentence, but you do need to talk about the validity of why t equals 6 is a better option. Does that make sense? These are not the exact words you need to use. You just got to be confident, point out the fact that this is more of a confident year time window than the other year prior. And then you also, the last part is stating that any value between t equals 2 and t equals 8 it also could be utilized because that's information that has been given. Okay.
I guess a lot of people are Alberta or Alberta.
I don't know why they're at lunch. We have sea lunch. You should tell your friends that. All right, next, our non-calculator. So now we're into the non-calculator, and this is our sinusoidal wave, right? So here you have the figure shows a clock standing on level floor with close-up view of the clock face, okay? The clock face has a 10 centimeter long moving hour hand. The center of the clock is 200 centimeters from the floor at the time t equals 0 hours. The hour hand is pointing directly up at 12. The next time the hour hand points directly up at 12 is at t equals 12 hours. As the hour hand moves, the distance to end point of the hour hand from the floor periodically decreases and increases. Does that make sense? Because it's going do, 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 in a circle. Okay. So when you this is a guaranteed question on the test. Okay. So you're going to be given this exact same graph with these exact same 5 points, and you have to decide how you're writing it out. Okay. Your F coordinates is where it begins. So we are at 0. At 0, we are at the hand on 0. We're 210 feet above the ground. That's our highest. Does that make sense?
These are my favorite ones.
Good. So 10 plus 200 is our highest point, correct?
Oh, we have to have those 5 points.
You just got to have those 5 points. Yes. Well, they split it. So if your X's are right, you get points and your Y's are right. So it's 2 points. So let's say
from F to P.
This is 2 points.
2 points?
Yes. Because they give you credit for the X's and credit for the Y's.
Oh, I see on the right side.
Yeah.
It's
2 points. So let's say you messed up on your Y's, but you got all your X's right. You got 1 point. Okay. Because a lot of times you guys do perfectly fine on your X's, and sometimes y'all mess up on the Y's. And so they give you credit for the X's, but not for the Y's. So as we're going around at 0, 3, 6, 9, and 12. And then our highest is at 0, which is 210. Our next highest, again, is at 12, which is at 210. And then from there, you can just find the center. Does that make sense? Because it has to be symmetrical. So to find our J, that's going to be your halfway point between, and our halfway point between was 190 at our lowest, because that's 200 minus 10, right? So 200 minus 10 put us at 190. And then the halfway point between 210 and 190 is 200. Yes. Okay, so that's 2 points for the X's and the Y's. Now, yours do not have to be mine because someone else could have viewed it differently and started their interval, but these are the most basic ones that you would put. There are actually multiple answers to this question. That's because sinusoidal depends on where you choose to start on the wave. Does that make sense?
But you just said like a Japanese.
Oh, I hear it. I heard it. On to the next. Okay, so now we're going to zoom in back in.
Wait, A equals 10. Right?
Which one? Yes, A equals 10.
Plus and A negative.
Where do you see negative?
Because
Because it depends on which way you created your graph.
I don't.
Yes.
A equals 10.
So we have A sine B. So because we have our highest, we have A equals 10. Once we found A equals 10, we're going to find our B. Remember, to find your B is how long is your period. Our period was from 0 to 12, so that's 12 units. So we take 2 pi over B, set it equal to 12. Once we take 2 pi over B and set it equal to 12, we then can cross multiply and divide. and we get pi over 6. So now we have our B is pi over 6. Your C is your what? What is that called? C is your phase shift. So for your phase shift, it's asking how far are you off from 0. And so our phase shift was at -9. And D is your midline, and our midline is at 200. Okay?
What if all right except for D?
Then they would give you partial credit. Yes, because the first part is A and D. So as long as you got A and D, that's 1 point. And then on B and C, you get half. Yeah. Okay. I would strongly encourage boxing your variables so that they don't have to look for them. And I'm going to encourage you always to go for the positive versus the negative. Okay. Yes, FRQ's on paper. So it'll be on the screen and then you have to write it on the paper, just like we've been doing. Remember how I've had y'all practicing looking at it on the computer and writing your answer on paper? That's how it's going to be set up. Okay. All right. So now we're on to part C. This is where first you have the multiple choice. Okay. So on the multiple choice, it's going to ask you, looking at the interval, it's always going to be the interval T1 to T2. So you're going to have to pay attention to what they label T1 as. This is what changes. This interval is going to be the same, but what they call T1 and what they call T2 is subject to change. Does that make sense? So for this problem, we're looking at J and K. So looking from J to K, I'm going to go back. I need it so you can look at our picture. Yep. So from J to K, describe what's happening here. It's positive and it's concave up, which makes it an increasing rate, correct? So now when we come over here and we select our answer, the answer is A. Okay? You just have to pay attention to what they change these letters to.
We circled A, that's all.
That's 1 point. Yep. And then it asks you, why did you choose that? And this is where you explain the graph is concaved up on the interval and the rate of change is increasing.
I put increasing.
Perfect. You have the words that they need. Does that make sense? Okay. I think we've done enough of these problems. I hope we're professionals and pros at. Okay. All right. Then our last non-calculator is going back to units 1 and unit 2 with a little bit of unit 3 in it. Okay. So when you look right here, we have the function g and h are given. So g is the log, h is the exponential, and it asks you to solve g of x equals 3. Okay. So you're taking g of x and setting it equal to 3. How do you cancel out a log? What's the inverse of the log?
So it's 4 to the third is 2x.
You raise it to the power of the base. So my base is 4. So I'm going to raise both sides to 4. Power of 4. So it becomes 4 to the third equals 2x. Now we're here. Well, what is 4 to the third?
No.
64.
No, 64, yeah.
So, and then you divide by 2 to get x by itself. It's all by hand. The numbers will be numbers that you should be able to multiply without a calculator.
I put x.
Yes, x equals 32 is the correct answer. Okay. On H, so on H, it says h of x equals e to the 1/2 for the value. So we're taking this and we're setting it equal to e to the 1/2.
Where you over?
Go down. Okay, so we're setting h of x equal to 1/2. H of x is e to the x to the 5th divided by e to the 1/4. First thing you're going to do is move this out of the denominator. In order to move it out of the denominator, you either can combine or you could just multiply this to the other side. However you choose to move out of the denominator, I really quite frankly don't care. But just remember, when you are multiplying powers, multiplying bases with the same power, what are you doing to those powers? What are you doing to those powers? When you're multiplying numbers with the same base, what are you doing to their powers? Adding. We're adding them together. We knew that. Okay, so you could choose that option. The other option is to make the base the same on both sides. Once your base is the same on both sides, all that matters are your powers.
So now you can.
And so now it just goes back to algebra 1, taking this and setting it equal to that. Does that make sense? So now it becomes 5x minus 1/4 equals 1/2. I'm going to add 1/4, which gives me 3/4. And I'm going to divide by 5, which gives me x equals 3/20. Okay, so you have a couple options here. Now, the thing with this problem is that it is about your computation skills. So they will give you credit if they can follow your work. So show all of your work and please clearly box your final answer. Okay, but show all of your work and clearly box your answer because they can see if you made a small mistake, right? But you knew the process. Okay. Any questions about solving either one of these by hand? Okay. You did? Oh. Okay. On the next part, we have functions J and K are given by, and we have J of X equals log base 10, X plus 1 minus 5 log base 10 of 2 minus X plus log base 3, base 10, 3. Okay. And the first thing it says is to rewrite it as a single log. Guys, we know our log properties. So we're writing it as a single log. Log properties, when you're subtracting, remember that's the quotient property, and when you're adding, that's the product property. Before you do anything, you apply your power property. And your power property says that your leading coefficient becomes the power of the argument. Do you remember that? Leading coefficient becomes the power of the argument. And now you're just going to write it as from left to right, the arguments. So I have x plus 1 here minus this. That means they're going to be divided. So we have x plus 1 divided by 2 minus x to the 5th. And then we have plus 3, and that means we're multiplying 3, so that belongs in the numerator. Things that are being subtracted belong in the denominator. Things that are being added belong in the numerator. Does that make sense? For our log and quotient properties. Oh, we're good. Okay. So remembering that. Now, sometimes I've seen problems where they trick you and the front is negative. So if this said negative log 10 x plus 1, if this is a negative log, that means it belongs in the denominator. So don't be tricked by the fact that it starts off as a negative. Only the positive logs go in the numerator. Their arguments go in the numerator. Okay. And then now it asks for you have to include the restriction. So there's a restriction because what can't happen in the denominator? Anyone? Everybody?
It can be less than
The denominator can't equal what?
0.
0. Your denominator can't equal 0. So you're asking for the values that would make your denominator equal to 0 or make your argument equal to 0. So all these things that could take place. Your argument can't be 0. Your argument can't be negative. So paying attention to these, well, it can't be 0. It can't be negative. I'm sorry. Your argument has to be greater than or equal to 0. Okay. So values that would make this greater than or equal to 0 would be -1 and 2. So my domain restriction would be between -1 and 2. Okay. Next is trig. So solving trig. So you're giving k of x equals secant x minus cosine x. And it asks you to rewrite as a product involving tan x and sine x and no other trigs. So it's going to tell you what it wants it to look like. So if my end game is to only have tan and sine, how can I turn this so that it only has tan and sine? So first off, starting off with secant, secant becomes 1 over cosine. Cosine is already cosine. Remember, our first thing is always put things in terms of sine and cosine. So now we're here. I'm going to use cross multiplying and dividing. Chopsticks in a bowl to make this into one fraction. So it becomes 1 minus cosine squared x over cosine x. 1 minus cosine squared x is a Pythagorean identity, correct? Pythagorean identity means that this equals sine squared x. So now I'm left with sine squared x over cosine. Quotient identities means that this becomes sine over cosine times sine, and sine over cosine is tangent, and sine is just sine. So did I make it only in terms of tan and sine? Yes. And I know that my restriction here is that cosine can't equal 0, cosine of x. Okay. The key thing here is I believe to get the full points, you do have to write restrictions, and there are going to be restrictions on part B. Okay. So there will be restrictions on part B. Next, here we have m of x equals 2 tan inverse of the square root of 3 pi x. Find all input values in the domain of m that yield the output of sine inverse of square root of 3 over 2. Okay, so m of x equals, so this is our answer. So we have m of x equals the inverse of square root of 3 over 2. Before you can set this equal to anything, you have to tell me on the unit circle, when do you get a positive y of a positive y value of square root of 3 over 2? And it has to only be in quadrant 1 or in quadrant 4 in order to satisfy tan inverse. Does that make sense? So it's making you remember all your rules that you have in place. So tan inverse, it only happens in quadrants 1 and quadrant 4, correct? So if I need a positive sign, that means it has to come from quadrant 1. In quadrant 1, when I have square root of 3 over 2, I'm at pi over 3. So that's what I'm setting this equal to. So now you have this set equal to pi over 3, and you're going to go through and solve it. There's always going to be a problem that you can solve without a calculator, okay? So the first step here to solve is to divide by 2. When I divide by 2, we're left with pi over 6. After I divide by 2, I then am going to take the inverse of tan tan inverse, which is just tan. So I take the tan of both sides. That sets this argument free. So we're left with square root of 3 pi x equals tan of pi over 6. Unit circle time. Go to pi over 6. What is y divided by x? Well, y divided by x is going to give me 1 over the square root of 3. After I do that, I then am now going to, goal is to get x by itself. So to get x by itself, I'm going to divide both sides by square root of 3 pi, and it simplifies down to 1 over 3 pi. So all of this is meant to be done strictly with no calculator and use of the unit circle. Okay, so knowledge of your unit circle is going to be prime. All right, once you get to the FRQs for non-calculator, if you have time and you feel confident and you want to, we've practiced doing our unit circle in under 5 minutes, under 3 minutes is what the goal is. And you can go ahead and sketch out your unit circle. What quadrant do you need from the unit circle? 1. That's our main quadrant, right? So even if it's just you writing out everything in quadrant 1, the radians and the ordered pairs for quadrant 1, at least you will have that written and it's not something you have to keep pondering about. Does that make sense? Okay, so make sure you use that time wisely. Because as you look here, this is all strictly based off of you knowing the unit circle. For tangent? For tan inverse, remember each inverse has quadrants that it's good in. So tan inverse and sine inverse are only quadrants 1 and quadrant 4. Then you have cosine and cotangent, which are only good in quadrants 1 and 2. Yeah? Remember the inverse lesson?
Yeah.
Okay.
Pie chart.
Okay. Your little pie chart. All right.
I know the pie chart.
Okay. So that concludes us going over